Good morning. Today we are covering Algebra 2 Lesson 8.3, Solving Rational Equations. And so far we've been working with rational expressions. Now we're going to deal with equations, something with an equal sign in it. And to do this, really there's a very simple process involved. Start out by looking at this simple fractional equation, x over 13 equals 6 over 13. Notice that the two denominators are the same. And in fact, one of the goals that you get to solve for x in any rational or any equation that's fractional, rational, which is what this is you get the denominators the same. And once you get the denominators the same, then you can solve for x. So, if I put a line through it, what am I left with? Well, x equals 6. That's the solution, because 6 over 13 equals 6 over 13. Simple as that. So look at the second one. X plus 5 over 13 equals 12 over 13. Ignore the denominator and just solve for x plus 5 equals 12. Subtract 5 from both sides. And you get x equals 12 minus 5 is 7. That's the answer. So you got these two answers, and all you had to do was make sure that your denominators were the same, and then you just ignore them. Okay? All right, so now we've got a few equations. We're just going to do a little practice. So x over 36 equals negative 43 over 12. So here, obviously, we've got to make the denominators match. So I'm going to write that. Make the denominators match. Okay? All right. So I've got x over 36 equals negative 43 over 12. And if you look at this, 12 is 3 times, 36 is 3 times 12. So multiply the numerator and the denominator times 3 over here on the right-hand side, and you get x equals, or x over 36 rather, equals, and then 3 times 43, I don't know what that is offhand, so 3, let's turn this on and clear it, 3 times 43 is 129, and you've got a negative sign in front of it, so it's negative 129 over 36, and again, just ignore the denominator. So what does x equal? X equals negative 129. And that's your answer. Okay? So, you can check it. So put the value x back into your original equation. Negative 129 over 36. That's going to simplify into some decimal. Let's find out what it is using our calculator. So negative 129 divided by 36 equals this negative 3.583333. So it's a continuing thing. Now, that's certainly not a fraction. So we can't check it that way, but let's put that down, negative 3.583 ... And then use the frac tool in these graphing calculators. So go to the math button. It's on frac. You hit enter and then answer frac, and you get negative 43 over 12, which is the other answer. So it checks. Okay? All right. So let's do the next problem. So I've got negative 3 over 25 equals 15 over x. So I want to get the denominators the same, and since these two are unlike each other, the only thing I can do is multiply times the opposite denominator. So I'm going to do that. So I'm going to multiply times 25 over 25 on the left, and I'm going to do x over x on the right. Multiply those together. So negative 3 times x is negative 3x over 25x equals, and then 15 times 25, use my calculator, 15 times 25, that's 375. So that equals 375 over 25x. And then just ignore the denominator. Numbers and x's included. And your solution is going to be negative 30. Oh, I said negative 36. It's negative 3x. Negative 3x. Right? Negative 3x equals 375. Divide by negative 3 on both sides. And I get x equals, I think that's negative 125. Let's take 375 divided by negative 3. 375 divided by parentheses negative 3. And you get negative 125. Okay? So, another answer knocked out. Got 2 of them. All right, the third one here. A little fish here, but I've got a 3 here and a 2 here. Both of these are prime. So I'm going to, again, multiply each denominator by the opposite denominator. And I'm going to do it, of course, as the number 1. So this is rationalizing, if you will. So I'm going to use 3 over 3. And this is 2 over 2. Okay. So when I do that, I distribute. So I'm going to put these in parentheses. Distribute the 2 to the 3x and the 2 to the negative 6. And over here I'm going to distribute the 3 to the x and the 3 to the 6. So 2 times 3x is 6x. 2 times negative 3 is negative 6. Divided by 2 times 3 is 6. Equals 3 times x is 3x. 3 times 6 is 18. Divided by 6. Okay. Get rid of the denominator. And you're left with 2 times negative 6, by the way, is negative 12. So let's fix that. Negative 12. Okay. Everything else is the same. 2 times 3x is 6x. Okay. So I'm left with 6x minus 12 equals 3x plus 18. And then I'm going to subtract 3x from both sides to get all the x's together. You know, all my x's live in Texas. 3x minus 12 then equals, cancels, 18. And then I add 18 to both sides. And so that, subtract 18 from both sides. So I want to get rid of it over here. And I beg your pardon. I'm off dreaming about quadratics and solving for 0. So at this point, I've got 3x minus 12 equals 18, right? I want to get the x by itself, so I've got to add 12 to both sides. And so the negative 12 and positive 12 cancel, and I get 3x equals 18 and 12 is 20. Not 20, 30. My math is sometimes a little shaky. Divide by 3, and I get x equals 10. And I have a good answer there. Okay, so getting rid of those denominators makes a huge difference. Okay, a little more complicated. So here, you notice I have binomials here, and this is a binomial as well. All right? So I'm going to have to multiply again because I'm using binomials here. I have to, when I multiply these two together, the 2 will be multiplied with the binomial. Okay, so we're going to do that. So in this case, I want to multiply both sides times 2 over 2. And over here, I want to multiply both sides times x plus 4 over x plus 4. So now I'm going to distribute the 2 to the 5x and the positive 2. And I'm going to, now down here, I've already got 2 times x plus 4 and 2 times x plus 4. So I can just leave that like it is because I'm just going to be eliminating it. I'm not going to bother with that. So let's just multiply the 2 times 5x. So that's 10x, right? And 2 times 2 is 4 over 2 times x plus 4 equals 7 times x plus 4. So 7x. Distributing here and here. Whoops. So 7 times 4 is 28 over 2x plus 4. And then this is where I get to get rid of the denominator and rewrite this as 10x plus 4 equals 7x plus 28. Let's get the x's together. Subtract 7x from both sides. And I get over here on the left 3x plus 4 equals 7 and negative 7x cancel equal 28. Now I want to get the 4 over with 28, so I'm going to subtract 4 from both sides, and I get 3x, this cancels, equals 24. Now I'm going to divide by 3, and I get x equals 3 times 8 is 24, so 8. So, good answer, okay? All right, so let's go on to the next one. Now this one's a little gnarlier. This is not a fraction, but I can turn it into a fraction. Put it over 1. Now let's use, so a negative 1 over 1 makes it still negative 1, right? So now I've got a 3, I've got 1, and a 3x. I'm going to have to multiply those all together. But the 1 really doesn't count because 1 times anything is whatever it is. So really all I have to do is, this is 3 times x. Over here I have to go ahead and multiply the numerator and the denominator times x over x. And so I'll have to get 3x as this denominator, and then I have to multiply this times 3x and this times 3x. All right? Numerator and denominator, so let's just multiply across. So negative 1 times 3 is negative 3x over 3x. And this is 1x or x over 3x. And this is 8 over 3x. Right? Get rid of those the denominator. Oh, gone. And so I now have negative 3x plus x equals 8. Negative 3x plus x leaves us with negative 2x equals 8. Divide by negative 2. And I get x equals 8 over negative 2 is negative 4. Done. See how easy that is? It's not bad at all once you get rid of the denominators. And that's what everybody, fractions just scare people, but they shouldn't. You do this, you're rid of them, okay? All right, here we want to solve for all values of x. So this is even a little more complicated. You'll notice we have, again, a bunch of binomials. There's one here in the numerator. There's one over here in the denominator. There's one here in the numerator, one in the denominator. All right, so I'm going to have to multiply the first fraction over here times x plus 4 over x plus 4. and then I'm going to, I have negative 4 over here, so I'm going to have to multiply the second fraction times negative 4 over negative 4. Okay? All right, so notice here I'm going to have to FOIL this. Can't get rid of it. So x times x is x squared. Can't get rid of it any other way. X times negative 7 is negative 7x. 4 times x is positive 4x, and then 4 times negative 7 is negative 28. Okay? And that's going to equal negative 3 times negative 4, so that's going to be positive 12. And let's just get rid of the denominator. We don't need it anymore. Okay, let's put our likes together. So I've got x squared. I got negative 7x and 4x. That's negative 3x. I've got negative 28. And that equals 12. Now, this is a quadratic, right? This is a quadratic equation because it has a leading term with a power of 2. So seeing that, we know that we can and we must set y equal to 0. And then we'll want to factor. And then lastly, we're going to want to solve for x. Okay. So to set this equal to 0, I'm going to have to subtract 12 from both sides. Okay, so we got x squared minus 3x, negative 28, and negative 12 is 8, 2 is 10, 2, 3, negative 40. And that equals, this becomes 0. So we've done the first. Now we want to factor. So I got to factor this. So I'll set up a couple of bubbles. X times x is x squared. What's negative 40 that when added together equals negative 3? How about, let's see, 5 times 8 is 40. So that's what, negative 8, positive 5. Right? So now I can go ahead, now that I've factored it, I'm going to solve for x. So I'm going to make x minus 8 equals 0. And x minus 8 equals 0, and then x plus 5 equals 0. So when I solve this, I'm going to add 8 to both sides, so I get x equals 8. So that's one of my solutions for x when y is 0. And over here, I'm going to get x equals negative 5, because I would be subtracting 5 from both sides. So those are my two solutions. Now, we want to check these, because you can sometimes get an answer that is not going to be usable. It's an undefined answer. So let's just do that. Let's check. We're going to plug this 8 back into this original fraction. So wherever there's an x, here and here, I'm going to put in an 8. So that means I've got 8 minus 7 divided by negative 4 equals negative 3 divided by negative 8. I'm sorry, not negative 8, positive 8. Because this is positive 8. Plus 4. Right? So 8 minus 7 is 1. So you have negative 1 over 4. And this is negative 3 over 8 plus 4 is 12. And that simplifies when you divide by 3 into negative 1 over 4. So it checks. Okay? You divide both of the numerator and the denominator by, or you reduce it by 3. Okay? All right, so that checks, it works. So let's do the other one. Same thing. We've got binomials. This time we're going to multiply x minus 4 times x. So this whole side will be multiplied by x over x, numerator and denominator. And then over here, we're going to multiply the numerator and denominator by the binomial x minus 4. So we've got some distribution going. So x to the x to the negative 7, 5 to the x, 5 to the negative 4. And we're going to leave this alone down here because we know it's all the same. Why don't we just get rid of it? So we're just going to do it right now. And x times x is x squared. X times negative 7 is negative 7x. And that equals 5 times x is 5x. And 5 times negative 4 is negative 20. So you have, well, let's put this all together. We want to make make y equal 0. So we're going to we're going to subtract 5 x's from both sides. And when we do that, we get x squared minus 12x. This goes away, equals negative 20. Now we want to get it to equal 0, so we add 20 to both sides. And over here on the left, we end up with x squared minus 12x plus 20 equals 0. Now we got y to equal 0. All right, now we're going to factor. So let's factor, double bubble. So let's see, x times x is x squared. 20, let's see, 5 times 4 is 20. But no, let's do 2 times 10 because when we add together negative 2 and negative 10, we get negative 12. So negative 12, I'm sorry, negative 2 and negative 10. So negative 2 times 10 is positive 20. Negative 2 times negative 10 is positive 20. Negative 2 and negative 10 equal negative 12. All right, so we got that right. And so now we want to, we factored, we're going to solve for x. So x minus 2 equals 0. X minus 10 equals 0. So this is going to be x equals 2. And this is going to be x equals 10. All right, so let's check this. Let's go ahead and check this. And I'm going to do both sides this time. So I'm going to check both sides. So let's put the 2 in. I should have checked it over here, but you know, this answer to this, we can do that. We can go back and do that. So here I'm going to plug a 2 in for x here. So I've got 2 minus 7 over 2 minus 4 equals 5 over 2. Well, what's 2 minus 7? It's negative 5. So negative 5 and 2 minus 4 is negative 2, which cleans up to 5 over 2. Okay. Over here, you got 5 over 2, which just comes down here, 5 over 2. Checks. Okay. Let's try 10. So we're going to use 10 this time, minus 7, divided by 10 minus 4 equals 5 over 10. So 10 minus 7 is 3. 10 minus 4 is 6, which simplifies to 1/2. Here I've got 5 over 10, which also simplifies to 1/2. So why don't we just bring this down and we check. Okay. So the check is good here and here. Let's check this one over here. So this one we had negative 5 for x. So negative 5 minus 7 over negative 4 equals negative 3 over negative 5 plus 4. So negative 7 and negative 5 is negative 12, I believe. So that's negative 12 divided by negative 4, which simplifies, let's see, 4 goes into 12 3 times. So, and negative divided by negative is positive, so that simplifies to 3. Here we have negative 3 divided by, let's see, negative 5 plus 4 is negative 1, which also negative divided by negative is positive. I end up with 3, so this also checks. All right, so everything checks here, we're good. Have you take a quick look at it all. Make sure you can see it, and then we'll move on. Okay. Okay, getting a little more complicated. So here, notice we have a 1, and then we have 3 over x minus 1, and oh look, we got a quadratic here, and that looks like to be difference of squares. Over here we have a binomial as well as here, and then we have a trinomial here, which is quadratic. So let's put bubbles around the things that we need to put bubbles around. And, okay, and well, let's put a bubble around this too. Okay, and this we don't need to because it's trinomial. All right, so I'm going to need to factor first, is what I'm going to need to do, because I got to take care of this here. So factor first. All right, so this is a linear factor, let's just start over here. So I've got x plus 5, and this is double bubble. So the difference of squares, so that's x times x, and then plus 1 and minus 1. Okay, difference of squares. And then over here, let's put the equal sign. Just working backwards, this is 3 over x minus 1. Now, notice I have an x minus 1 here, but I got an x plus 1 here. So I'm going to have to multiply this times x plus 1 over x plus 1. So I'm going to move over a little bit. 3 times x minus 1 in parentheses, and then we're going to multiply that times x plus 1 over x plus 1. Okay, and then I've got this 1, and so that's 1 over 1, and ones are all implied here, so I'm not going to even bother with putting them over here. But I've got to do x minus 1 and x plus 1, so I'm going to do that. So times x minus 1 and x plus 1. Kind of smush them in there. And times x minus 1 and x plus 1. Okay. And that was added. So make sure we put the plus sign back in here. And that's plus this equals, yeah, this. Okay. All right. So now, all the denominators now are the same. X minus 1, x plus 1, x minus 1, x plus 1, and so forth. So we're going to just get rid of it. Because it's too busy. It looks difficult when you got it that way. And what are we left with? All right. So we got to FOIL this. So x times x is x squared. X times 1 is 1x. you know what, we're going to end up with this is going to be difference of squares again. So why don't we just cut to the chase and say it's x squared minus 1. But x squared plus 1x minus 1x is x squared minus 1. Okay? Saves us a little space, and then we have 3 times x, and 3 times 1 is 3. So that leaves us with plus 3x and then and plus 3. Right? And that's going to equal, and then over here we just have the x plus 5. See how that really simplifies? All right, so we got a -1, a -3, and well, we want to get rid of the x's first, this x first. So let's subtract x from both sides. And so we're going to get rid of that. And what are we doing again? We're setting to y equal to 0. So set y to equal 0. And then you're going to factor. And then you're going to solve for x when y equals 0. Okay. So, leaves me with x squared minus 1. This becomes 3x minus 1x is 2x. So plus 2x plus 3 equals, this goes away, equals 5. Now I want to set this whole thing to equal 0, so I'm going to subtract 5 from both sides. Now, when I do this, you notice I got a -1 here, I got a 3 and a -5. So all those are going to get combined. This one, and this one. So we might as well just combine them all at once. So -5 plus 3 is -2, and then -2 and -1 is -3. So I'm going to rewrite this as x squared plus 2x minus 3 equals 0. And then pot's right. All right. Factor, double bubble. So I got x times x is x squared, and then what times what is -3? That when added together is positive 2. That's got to be plus 2, what is it? Plus 3 and minus 1. Plus 3 minus 1. Okay? So 3 times -1 is -3, and then 3x and -1x is 2x. So it all works out. All right, so now let's set x plus 3 to equal 0 and x minus 1 to equal 0. And so here it solves, you subtract 3 from both sides, so you get x equals -3. That's your first solution. And then this, you're adding 1 to both sides, so you get x equals 1. Okay. All right, so you want to check. So this is -3. I'm going to put it into the original equation again. So I start out with 1 plus 3 over, and then I've got -3, okay, minus 1. And that equals, x is now again -3 plus 5 divided by, and then I've got x squared, so -3 squared minus 1. Okay. All right, so let's clean this up. So I have 1, and this is 3/4. 1 and -3/4. So 1 minus 3/4, well, that's going to be 1/4, right? And then over here, I've got -3 plus 5, that's it's positive 2 over -3 times -3 is positive 9 minus 1. So that's 2 over 8, which equals again 1/4. So that checks. Let's do x equals 1. So if x equals 1, I'm going to have 1 plus 3 over 1 minus 1. Okay. 3 over... Let's try this again. 1 plus 3 over 1 minus 1. So what's going on there? Let's just finish this. 3 over 1 minus 1 equals 1 plus 5 over 1 squared minus 1. So that becomes 1 plus 3 over 0 equals 6 over 1 squared is 1 minus 1 is 0. So this is undefined. You can't go any further. Whenever you have zeros in the denominator, that's illogical, as Mr. Spock used to say. So you can't do that. You gotta make sure that you have an answer that has values in the fractions. So this is a bad one. We can't use x equals 1. We can use for your solution x is -3. Okay. All right. Let's go on to the next one. So we're going to have to factor first. So I'm going to have to factor this. So x squared plus 9x plus 20 factors into x times x, and what times what equals 20. That when added together is 9. That's 5 times 4 is 20, right? So plus 5 and plus 4, and that's over 3. And then this one is 3 over x plus 4, so we're going to have to multiply it times x plus 5 over x plus 5. So I've got 3 over x plus 4, and then I'm going to multiply that times x plus 5 over x plus 5. Now this is 1, so it's not going to be an issue because 1 over 1 is 1, and then the denominators are going to be the same. So it's the same issue as before we did over here. Just to make it all work, this is 1 times x plus 4. Now let's do it this way. 1 over 1, and then this is x plus 4 times x plus 5. So x plus 4 times x plus 5, and this is x plus 4, it's x plus 5. Now, all these are x plus 4 over x plus 5. So we can get rid of the denominator. So what are we left with? So I've got, this is foiled, so I want to foil this. So x times x is x squared. X times 5 is 5x. 4 times x is 4x. And 5 times 4 is 20. Right? And then that was that added? Yeah, this was added here. So I put a plus sign there. So I've got plus, and let's distribute 3 to x and 3 to 5. Right? So 3 times x is 3x, and 3 times 5 is 15. And this is just 3. Good, because we're running out of space. All right, so this is 5x and plus 4x. All right, so I've got x squared, and then I have 5x and 4x and 3x. 5x and 4x and 3x. So 5x and 4x is 9x and 3x is 12x. So I'm going to have x squared plus 12x plus 20 plus 15. That's 35. And that equals 3. All right. Now I want to set y to equal 0. So I have to subtract 3 from both sides. And so this cancels. So I end up with x squared plus 12x. This is 32, right? Plus 32 equals 0. Now I've set y to equal 0, and this is looking a lot easier to handle. Let's double bubble it. Factor. So x times x is x squared. Now what times what equals 12x? That when added together, when multiplied together equals 32. So 4 times 8 is 32. So plus 4 plus 8, right? So I've got, just check the rainbow as they say. I got 8x and 4x is 2x. Okay. So now I'm going to factor it. I'm going to solve for x. So x plus 4 equals 0. X plus 8 equals 0. So subtract 4 from both sides. I get x equals negative 4. One solution. And I get over here, I subtract 8 from both sides. I get x equals negative 8. Now I got to check. All right, so I'm going to use negative 4. So I've got original equation. Remember, don't, we've added things and multiplied things to all of these fractions. Only use the original equation when you're checking, okay? So this is 1 plus 3 over, and then x is negative 4. Negative 4 plus 4. So we did that right. Yeah. Okay, well, let's keep going. This doesn't look good. Looks like we got an undefined going. So that equals 3 over negative 4 squared. Plus 9 times negative 4 plus 20. All right, so this 1 plus 3 over 0. It won't work. Now I can tell you, we could go on with this, but once you hit one of these, it's undefined. So now let's do the other one. We're kind of out of room, so I'm going to just do it this way. And so we're going to check for negative 8. So I'm going to use so this is for x equals negative 8. So I have 1 plus 3 over negative 8 plus 4. And that equals 3 over negative 8 squared plus 9 times negative 8 plus 20. All right, so this is 1 plus, now that's 3 over negative 8 plus 4, that's 1 3/4, isn't it? But it's negative because you got a negative sign there. So we'll change this to 1 minus 3/4, which equals 1/4. Okay? And then this is 3 over negative 8 squared is positive 64. 9 times negative 8 is negative 72. And then we have 20. So this is negative 72 here. 64 minus 72. So 60, turn this on, clear. 64 minus 72 is negative 8 plus 20. It's 12. So I've got 3 over 12, which simplifies into 1 over 4. Checks. Okay. So the first one was undefined. Can't use it. You use the negative 8. Okay. All right, we are done. We're actually done with this thing. Let's make sure you can see the whole blooming thing. So I'm going to move this up a little bit so you can get it all. Okay. And we are done. Have a wonderful afternoon. Thank you. Bye-bye.